There we go. Okay. Hello. What's wrong with this? It's looking a bit faint, isn't it?
Really faint.
Yeah. Oh, I picked pencil, thanks. I need to pick pen. There we go. Okay, so what ID number first?
363.
363. What was wrong with this one?
Question B.
What's wrong with question B? Why is that a problem? I don't see what's so difficult about this. What's the problem with it? What's the problem with it? Guys, what's the problem with it? I'm going to do this and it's not going to be that difficult. So let's have a look at it. I mean, I understand that there's some questions going to be difficult, but I don't know. Okay. So what have we got going on here? We've got a tension, correct? Now we know how much the tension is. What is it? 600 newtons. And the tension here? 600 newtons. Now you worked out the angle from the first part, didn't you?
Yeah.
What was it? 67.4.
Yes.
Okay. So you know this angle? 67.4 is it, or?
Yeah.
Yeah, and we know this angle? 67.4. Okay. So we know what this whole angle here is. What's 67.4 times 2?
134.76.
134.76. Okay. Now we know this angle.
112.
112.6.
112.6.
Yeah. 0.6. And what's this force here? It's mg. Yeah? So you have mg over sine 134.76 equals 600 over sine 112.6. So then m will equal 600 sine 134.76 over 9.81 sine 112.6. So what do you get here for m?
461.2 Newton.
No, kilograms.
Oh, 47 grams.
Thank you. Now I still want to know what was so hard about that. That was such an easy question. It was exactly like what I did yesterday. It was exactly the use of the second formula of Lamy's theorem. What was so difficult about that? No, seriously, like, what was so difficult about that? I need to know. Anyone?
The way the question was put.
How? I can't understand what was difficult. Guys, I need to know because I have Lorraine talking to me and I have Neil talking to me because this class is saying that the content is too difficult and too fast. So I need to know what the heck the problem is. So what am I missing here?
It's just like the way we used to treat the question.
Yeah, visualizing how it's supposed to look is kind of an issue.
But you have the diagram right here.
Yeah, because you
Yeah, because
broke it down and actually have the diagram, but the way to just put it all together was the issue for me.
Yeah, but when I did the examples yesterday, did I not do an example exactly like this?
Oh.
Like literally, I had something hanging from 2 strings from the ceiling, didn't I?
Yeah.
I think the only difference was I put the theta up here, right? So again, my question still is, what the heck am I missing? I really am baffled by what the confusion is. Lorraine asked me to talk to you guys today about what we can do to help the physics. So I'm trying to get some information out of you. So if I don't get information, I can just go back to Lorraine and say, well, look, I asked them like you asked me to, and I'm getting no information from them. So like, I need to know what the heck you need. What's the problem here? Because I've done an example just like this. So like what am I missing? I'm missing something and I need to know what it is. It's driving me nuts.
I was confused by use 600 newtons
Yeah, exactly.
for
The way the
maximum
question was
or
posed.
use a less.
Which part here? The 600
Yeah,
newtons?
it says,
600
given that the wire will break under a tension T of 600
Yeah.
newtons,
So if you use
calculate the
600
maximum
pro-
mass allowed for the
Okay.
that's what
Okay.
I think.
So
Confusing.
if you prefer then, what you have then is this is the maximum that will cause it to break. So if you want, you can give your answer like this. The mass must be less than less than 47 kilograms. If you prefer, you can give the answer like that. That's going to get you full marks as well. They're looking for the maximum mass, the mass that would break it, which is 47 kilograms. So anything less than 47 is safe. Anything more than 47 will break it. And equal to 47 means you're taking a chance. Yeah. So, okay, alright. So, anyways, before we do anything else, you should write that down if you need to. So that was number 2. Okay, what's the next one here?
Will be, are we going to be forced to like use Lami's theorem? Like you can use like resolve the forces.
They never force you to use Lami's theorem in the exam. So what they'll do in the exam is they'll just give you the diagram and say, like here, find the mass. Now what I've discovered though is for some questions in the exam, Lami's theorem is the quickest way. You were saying here you resolved.
Yeah.
You made them equal and you got the mass. That's fine. That's fine. So maybe Lamy isn't such a super help here for this one. But, you know, I'm looking at other questions. I'm looking at, like, question 3. And I really think for number 3, maybe Lamy is the quickest way here for it. Yeah. Anyways, what do we need to see next? That was number 2. Number 3. Okay.
Honestly, I use the Tokyo. Tokyo is faster.
Which method?
Tokyo.
The torque.
Yeah,
Turn in force.
yeah,
You think it's faster?
yeah.
Yeah? Okay. Well, that's fine. I'm going to use Lamy, just because I like Lamy's theorem. That's fine. Now, again, before I continue, what was the problem with number 3? Because number 3 was exactly like an example I gave you, wasn't it? Yeah, so what was the problem with number 3? No? Like, no problem? Or there is a problem?
I don't know.
Like, there's nothing peculiar about this one, is there? There's a string, there's a weight.
You should give a lot of information.
Yeah, in fact, it's probably a little bit easier than the example I gave you, because in the example I gave you, I think there was a weight at the end.
Yeah.
I put a weight here at the end of the trapdoor, but I don't think in number 3 there is a weight at the end, is there?
No.
No. And I can do number 3. I can do number 3. Okay. Tray. Right. There's the trapdoor, and there is the weight here, 5.64 G, isn't it? And then there's a tension here, T, isn't there? And this is 25 degrees. And then there's a reaction here. Yeah? And these all meet, I'll put it in green actually. They all meet here. Yeah? And what are we looking for? Oh, they don't call it T, they call it Q.
And then the distance as well.
What distance? Oh, you have the distance?
Yeah.
0.9.
0.95.
Okay, so can someone just divide that distance by 2? We can have that distance. What's that? 0.4476. Okay. Let's see. I'm going to get this length here. So actually, you know what I'll do? I'll draw 2 triangles. So this side here is 0.476. This is 25.
Yeah.
So this side h, you can say tan 25 equals h over 0.476. Oh, thank you. What is it? 0.22. Good. And then if I look at the triangle on the left, I have 0.22 and 0.476. Oh, actually, I didn't really. So I know that this must be 25.
Yes.
The 2 triangles are identical. That's actually really, really nice, because it means here you can say or cos 25. That should equal Q cos 25, right? And then or sine 25 plus Q sine 25. That's equal to 5.64 G. Now, what am I looking for? Or a Q?
Q.
I'm looking for the Q here. Okay, but look, on this equation I can divide. So what do I know about or and Q? They're equal. So this or and this Q are the same. So I could replace this with Q. So very good. 2Q sine 25 equals 5.64 G. So why is this one easier than the example I did yesterday? Because the triangles are the same, aren't they? And what did that mean about or and Q? They're the same. So was it really a simultaneous problem?
No.
Not really. So it was actually easier than the example I did in class. Kayhan, when you used torque, was it much quicker than this?
Yeah.
Really?
Yeah.
This is pretty quick though.
I think it's same because I use Tokyo with one long equation and this is 2 short equations.
Yeah, so one long equation or 2 short equations, it's pretty much the same. Okay, so what's the Q here? 65.5 newtons. Oh, wait a second, hang on, Jeffrey and Kayhan, you're both speaking Chinese, aren't you?
No, I speak.
No. Can you swap with Jeffrey, please? Thank you.
The solution, they actually use the to clockwise.
The solution uses turning force. Well, this is what Abdul Rahman was asking me. Do they make you use a method in the exam? And they don't. How many marks was that actually in the solution? For the whole question 3? 4 marks?
1E, 1E, 1M,
4 marks?
What does the M mean?
M is a mark for the method, and A is a mark for the answer. Okay, what will we do next now? What's the next one? Yeah, what question do you need me to do next?
Number 6.
6?
Oh, sorry, but before when it asks you to do horizontal component and vertical component, just put 740 cos 90.
What do you mean horizontal and vertical
The
component?
axis resolves the forces vertically, resolve the forces
Huh?
horizontally.
In number 4?
5.
Oh, number 5.
Yeah.
Oh, yeah. Well, that's just getting the X and the Y. So, Yeah, I suppose actually, Abdul Rahman, you're asking me, do they force you to use the method? They don't, but when I'm looking at question 5, they really, really kind of want you to do it the other way. No, not Lammy's. Because they ask you to resolve. You see in number 5?
Yes.
So, do you know what? I think what I'll do is I'll move number 5 into the previous lesson. Maybe into cantilevers and further support. Yeah, I think that's what I'll do. Yeah. So,
But I did the number 5 with Lamis.
yeah, good. Good. I would like you to do that because we were practicing Lammy's theorem. So, right. Anything else?
Number 6.
Oh, what's wrong with number 6? Did you try it?
Yes.
And what's wrong with it? What's difficult about it?
The last one. Angle theta.
The theta, yeah. What is the theta here? Okay. Did you get any of the angles?
Yes, sure.
Okay, let's have.
One between F and
Let's have a look. Okay. 6. So here we have one force, another force, and another force. And what do we know? Oh, we know the T, don't we? It's 2300. We know the weight, don't we? What is it? 200 G. And do we know anything else? No. 200 G. No, we don't. Okay, well, the first thing is what's the weight? That's easy peasy. That's 200 G. Yeah, so what's that? What is it? 1962 newtons. Okay. Now, what do we want next? They want the F. Now that's a thinker. So we know this. We know this. Do we know this angle? Not yet.
That's what we're talking
That's that's for the last part, isn't it?
That's what should be first.
I
So
think the question 3 should be solved before question 2.
yeah. It would be easier to do number 3 first, wouldn't it? This, I don't know if I've told you this before. I know I told the other intake. Sometimes in the physics exam, you notice that sometimes it's easier to do the next part first, to do the question out of order. And I don't see any problem with doing that. There's no rule in the exam that says you have to do the questions in order, you know. So, I kind of agree. I think it would be easier if we get the theta first before we do anything else, do you know? Because we know that if we resolve here, that this component must equal 1962, right? It has to, because to cancel this. And that kind of, oh no, maybe, okay, no, I will do it in order. I don't have to get the theta, because what I can do now is if I call this x, I can use what? Pythagoras. I can say x squared plus 1962 squared equals, yeah, 2300 squared. Okay, so what do we get for x now? One, two. Oh. That's a familiar number, is it? No, just it's a nice number. 1200 newtons. Okay, and lastly, how do I get this angle? Tan inverse what? David?
1962
Yeah, good.
over 200.
Good. Wait. So if I know this angle, David, how do I get this angle?
You angles in the triangle. 180.
Yeah, so I could just do 180 minus 90 minus
Yeah.
that. Okay. So my next question is, why couldn't you do that last night, since you could tell me right now how to do it?
I wasn't sure of the transports.
Of which one?
Of
The 1962?
yeah.
Yeah, okay. Yeah, fair enough. You had to know that that equals that. Why? Why must that equal that?
Opposite forces are
Yeah, because the system is
resolved.
in equilibrium.
Yeah.
Sorry, the number
Yeah.
3 part, can you like write it again? I didn't quite get.
Which part, number
Yeah,
3?
the number 3.
What do you want me to do with number 3?
Could you like, I don't know, 90 minus 10 inverse
Yeah.
of
1962 over 2300. What part's confusing here?
Okay, I got the total angle is 90.
Yeah. So what angle is that then?
4 times.
Mm. 49.5? Thank you. Thank you. Kayhan, did you get the angle before the F?
Yeah.
And did you use Lamy?
Let me check. Yeah, now.
Yeah, Lamy. Okay. Oh yeah, so I actually,
No, I just use the balance, the force balance.
yeah, like what I did.
Yeah.
Yeah, okay. So, well, I kind of used Lamy because I needed to know that all these forces meet here, so I can get this angle. Kind of Lamy.
So before you use the Lamy, you should get the angle first. So I use the force balance to solve the question 3 and use the Lamy.
Yeah, no, I get you, yeah. Right, what's next now? What's next? Is that okay for the first homework? Yes or no? That sounded like someone said no. Is there anything we need to see from the first homework still? No. Okay, what about the second homework? Work.
Okay.
There's just the 4 questions there.
But then don't you just get the x angle, not the theta? If you
That's
go
why I did
40,
90 minus.
I thought 90 minus x.
I did 90 minus to get the theta, because this angle here is this. Is that 49.5 after you do 90 minus? Yeah. Yeah.
Okay, the angles are.
Yeah, it's a triangle here. This is the tan inverse, and 90 minus the tan inverse gives me the other angle. What about from the work homework? Was there anything difficult from that? No? Yes, actually they all look straightforward, don't they? Yeah, actually the work homework was much easier than the Lamy's one.
Yeah.
Okay. I'm going to move from Lamy question 5 into the previous homework on cantilever and further support. No, not question 5. What did I? Question. Which one did I say earlier? Oh yeah, 5. Yeah. Do I? Will I? Maybe. Yeah. Okay. No, I will. Okay. Right. Now what? So I could start the next topic. What is the next topic? I'll get a start on the next topic anyways. Okay. Yeah. Oh yeah, so before I do actually, take you to Moodle for a second. Okay. Right, just want to show you something on Moodle. Let me stop the recording.